Okay, so this is a real exam standard question. It will be 5 marks, and there's quite a bit to do here. Now, what we're told in the question is as follows. You've got an octagon on the outside. There are 8 sides. So I'd like you to draw that, right? Draw this on the outside. You've got an octagon there, and using the base of the octagon, you've got a pentagon. Right, this here is a pentagon. So you've got octagon on the outside, pentagon on the inside. Draw each of the points with letters. That's A, B, C, D, E. That's just the points, the vertices. And A, B, F, G, H, I, J, K. Draw that. And you're told 2 bits of information in this question. You're told that A, B, F, G, H, I, J, K, which is this, is a regular octagon. Like I mentioned, you have to be told if an octagon is regular. Remember, we said regular means they have all the same interior angles and all the same sides, but you can't go by the appearance. Now, I haven't drawn this regular octagon particularly well, but you're not expected to measure each of the sides using a ruler. You need to be told if it's regular. So we're told it's a regular octagon. We're also told that ABCDE, i.e. the pentagon, has one line of symmetry. Now you might think, where does symmetry come into this? So that's something for you to think about. Now, you're told to find x. Let me show you where x is. X is this angle over here. So what I would like you to do is to draw this, which hopefully you've started to do. Try draw it as accurately as you can, so it represents this diagram. Jot down those 2 bits of information. I'd like you to write that down. And this is a model exam question, so I'd like you to give it a go. So write that down as well, so you've got that in your notes. And I would like you to use what we've learnt to find the value of x. So when you've got that down, press pause. And then when you've finished, press play, and I'll go through it. Okay, so from this diagram, where do we start? Now notice x is part of the interior angle of the octagon. Remember, the interior angles are at each corner. So what makes sense is to start by working out the interior angles, the ones we don't have, from a pentagon. Right, the pentagon over here. Now, we can see that the pentagon is not regular because the angles are different. Right, they're not the same. Right, we've seen that straight away, so that's not even a question if it's regular or not. Now the pentagon, which we're told it's a pentagon, you can also count there are 5 sides, we can work out the sum of the interior angles. That's usually how you start these questions. So what I would do here, let's actually do the calculation in the pentagon. So you've got 5 sides, take away 2, you would have 3, multiplied by 180 is 540. That's the total interior angles. Then what we can do is we can add up the angles that we have. That's a similar process to what we saw in previous exam questions. 112, 112, and 84. So let's do that over here. Let's do 112 plus 112. You need to write this down. You can't just say, oh yeah, in my head I'll do it. You've got to write this down. You need to show working for the examiner. Plus 84. That is 308. Then we take away the 308 from 540, because I know the total interior angle is 540. These 3 angles here is 308, which means the remainder, the unallocated angles, right, the ones we haven't talked about yet, must be the difference. So now let's do 540, take away these ones I added up, 308, again, a separate line of working. Which is 232. Now, because this is irregular, how do I know? How do I know? Do I split it in, how do I split the 232 between the remaining 2 angles? If it was regular, I would know they're equal. So when you're working with a pentagon, you have to make sure we've read all the information in the question about the pentagon. Now look what it says. ABCDE pentagon has one line of symmetry. One line of symmetry. Why is that relevant? How do I use that? Did you work that out? Well, okay, let's talk about one line of symmetry. Where is that line of symmetry? Do we know where the line of symmetry is? Well, hopefully it's obvious from the diagram. Because if 112 is over there, and 112, it's like the 112 is looking at the other 112 in the mirror. So the line of symmetry must be bang in the middle between the 112. So imagine you're that 112, and that's the 112. So there must be the line of symmetry must be there. So therefore the line of symmetry we're drawing is through this point here. Right, but what's the line of symmetry got to do with anything? So if that's the line of symmetry, that's a mirror. That means everything to the left of the mirror is the same as everything to the right of the mirror. It's like when you look in a mirror. What stands on the opposite side of the mirror, you can see inside the mirror, as it were. So that 112 is the same as that. That 84 is split exactly in half. You've got 42 over there and 42 over there. But really, the most important thing to recognise, if that's the line of symmetry, then this angle here must be the same as that angle there. Which means that the 232 that we've got, we can split exactly in half. So, further down your calculation, the next thing you need to write is that 232, okay, divided by 2 is of course 116 for both 116 and 1. So I now know that that is 116. Nothing to do with the fact it's regular. It's not regular. It's because this line of symmetry forces all the angles on this side to be exact mirror images of the angles on that side. So that's 116. Now, what do we do next? We've only really dealt with the pentagon. So let's think what we do next. So X, you can see, with the 116 makes up an interior angle, a complete interior angle of the outside octagon. So let's work out the interior angle of the outside octagon. And if we take 116 away from that, we're going to get X. So how do I work out the interior angle of the octagon? We have to be careful. Although the pentagon was not regular, I can see that by observation, we were told that the octagon was regular. They said that in the question. So let's work out the sum of the interior angles of an octagon. Right? An octagon has 8 sides. You can also count the sides if you wish. There are 8 sides. So the sum of the interior angles for an octagon is 8. Remember, you have to take away 2, multiplied by 100, which is 1080. 6 times 180 is 1080. That means the total angles, interior angles of that octagon are 1080. Because it's regular, each of them are the same. Now an octagon has 8 sides, so an octagon has 8 angles, 8 interior angles. So let's now divide 1080 each by 8 to give me this interior angle, the same as that, but this is the one I really care about, which is 135. And now this whole angle is 135, that's 135, that's 135, and therefore the difference from 116 to 135 must be X. So again, finish it off correctly, 135, take away 116 is 19 degrees, and 19 degrees is the answer. Quite a lot we had to write down there. It was 5 marks, and I hope you followed that and you were able to get 19 degrees. If you didn't get that, it's well worth repeating that question. Hopefully you understand it now. It's really important, a 5-mark question. Go back, do it again. Right, draw this all again, or cover up what you've done, repeat it until you get it right. Okay, second problem. Quite an involved thing going on here. So on the outside there's an octagon, and here's a pentagon, and here's a pentagon. Now, you don't go by the scale of the diagram, you have to look at the information in the question. What does it say? A, B, C, D, R, E, F, P, G. And again, if you get overwhelmed by that, just follow where that's going. Look, A, B, C. So it's A, B, C, D, R, E, B, all the way to G. It's basically talking about the outside. That's just the way we do it. We do it with letters. We've done it with angles before. Okay, you follow all of those letters. It tells you it's regular. Okay, that wasn't obvious. Doesn't quite look like it, but apparently that's a regular octagon. PKLQF, where's that? PKLQF, that's this. That's a pentagon. MNREQ, that is also a pentagon. We're told they're both regular pentagons. Okay, they're both regular pentagons. Okay, so the octagon is regular, that's regular, and that's regular. That's good to know. So we have to find x. That's all we're told. So regular octagon, regular pentagons. Can you please draw that with all the letters? And can you use what we've learnt to find the value of x? So copy that down, then press pause and have a go. Okay, let's see what you did. Please follow my calculation and see if you got all the important points, all the bit of the calculation. As always, you must realise it's not just about the final answer, it's about the steps to the final answer. So we're told that we've got a regular octagon, and if you're a regular octagon, you do not need to be given any angles, because all the interior angles are the same, and therefore you just need to be able to work out one of them. So with a regular octagon, there are 8 sides, so it makes sense to work out the sum of the interior angles first. So we know the sum is n minus 2 times 180, we've seen that several times now. So if you take the 8 sides, you're going to have 8 minus 2, so you've got 8 minus 2, which is 6, multiplied by 180, which is 1080. That's the sum of the interior angles. It's an octagon, so there are 8 equal interior angles. So let's take the 1080, separate line please, divide it by 8, and we get 135. That tells me that each interior angle of the octagon is 135. So there, there, there. But I'm more interested in labelling it down where the pentagons are, because that's going to lead me to get x. There's no point labelling it there. How's that going to connect to x? It's not. So what I suggest we do is recognise that this one over here, remember it's the complete interior angle of the octagon. You kind of just have to blank out your mind that line, because the outside octagon is what we're interested in, and the interior angle is the angle at the corner, each corner of the octagon. So this here is 135, is that whole angle over there which we've just calculated. Now, what we can also do is we can work out the interior angle of a pentagon. Usually if you've got a pentagon or whatever polygon, if you work out the interior angle, that's normally the way to go. So we've got the pentagon. We were also told that the pentagon was regular, so we can do the same process. So for the pentagon, I can do 5 subtract 2 multiplied by 180, which is 3 times 180, which is 540. So the total interior angles of the pentagon are 540. Let's take your 540 total angles, divide it by 5, because there are 5 equal interior angles, which is 108. So that 108 is just this bit over here, just from there to there. Just from there to there, that is 108. Which means the difference between 135 and 108 must be just this bit over here. Let's use a different colour. So this bit over here must be 135, take away that 108. Again, you must write that down. 135, take away 108, which of course is 27. So this bit over here is 27. However, what you could recognise, and there's a few different ways that you could conclude this, is the same scenario is going over here. This 135, which was an interior angle for the octagon over there, well, the same interior angle exists over here. That's also an interior angle. So this is 135. That's 135. And this regular pentagon over here, okay, is the same. It's still that's a regular pentagon and that's a regular pentagon. So they're both regular pentagons. So this 108 over there, which was an inside interior angle for this particular pentagon, they're all 108 there. Well, these are all 108 as well. So the point I'm trying to make is this is 108 as well, which ultimately comes down to the fact that this is also 27. Okay, this is also 27. Also, for a regular octagon, you can recognise there's a line of symmetry right there, so you probably could have got that a lot quicker. However you got the answer, I don't mind, as long as you recognise that these are both 27. And the final thing to recognise is that in a triangle, the angles add up to 180. So let's add up the two 27s, 54, and subtract from 180. Now, don't do all that in your head. got to write it. Whatever you're thinking must be down on paper. So finally, let's write that down. So we said you've got to go down here. 27 plus the 27. These two 27s is 54. And x must be the remainder up to 180, because the three angles here add up to 180. It's a triangle. It's a triangle. Okay, it's not an equilateral triangle. It's not a regular polygon, right? But you can see that if you now do 180 minus 54, you get 126. And that's the answer. So just to recap, we first of all worked out one interior angle of a regular octagon, which was the sum divided by 8, which is the 135. We then worked out just a regular polygon, a regular pentagon, the interior angle, which was 5 minus 2 times 180, which was 540 divided by 5, 108. The difference between the 135 and the 108 was 27. We then recognised that the other side was also 27, and then used the fact they add up to 180, gave us 126 as the final answer. Again, a classic type of exam question there.